Hello and Assalamu alaikum everyone. I'm Dr. Afzal Badsha, and today in this video we will cover in detail the OSI model, the 7 layers of OSI model. The OSI model is actually a fundamental concept. These are the fundamental principles which are used to communicate on the computer network. If two computers are connected with each other, A is connected with B, then how the data is sent from the device A to the device B. So the basic principle, the basic methodology behind this communication, when we talk on our mobile phones, when we send our data, or when we send the email, the basic principle behind that, behind this communication, behind this exchange of data is the OSI, the 7 layers, the OSI models. So, for example, it is just like a daily example. If you want to send any gift to your friend, you want to send this to the post office or any other postal service. What do? You get any gift, you wrap it, you pack it, you just create its packet. You write your friend address, you write your own address, and after that you dispatch that. So after that, the postal services take this packet take this package and forward towards the destination, towards your friend address, according to the rules and regulations. So exactly the computer network works like that. Exactly such like rules are used to communicate your package, to communicate your data on the computer network from sender to the receivers. And basically this process from taking data from one device and sending data to the receiver device, actually this process, these steps are divided into certain layers, into 7 layers, for understanding, for troubleshooting, and for any other purposes. So this videos, either you are a professional, either you are a student, or either you are preparing for an interview or a test, this video can help a lot, because we are going to look in detail the every aspect of these layers, and how actually this data is communicated. The OSI, Open System and Connection, which is basically developed by ISO, and these were, or you can say, these are the fundamental principle for data communication on the computer network. OSI model is not practically implemented. The layers or the model which is practically implemented is the TCP/IP. But in the classes, for our theoretical understanding or research purposes, for teaching, we use the OSI model. So OSI model is actually a theoretical concept. It is not practically implemented, but the TCP/IP layer, which is practically implemented, exactly works like that. But if we teach the TCP or IP to our student into our classes, then students will not be able to get the concept exactly how it should be, because the TCP IP is merging many protocols, they are merging many layers, and comparative to that, OSI is beautifully categorized, that the students, particularly the new students, the people who are new to the network, can easily understand the concept of the OSI model, or the OSI layer, or the working of the computer network. The basic layers, the 7 layers of the OSI model, is the physical layer, network layer, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. We will cover all this in very detail, but first look at these categorization, particularly the basic two categorizations of the network layer. The basic categorization of the OSI model. The OSI model layers, which I discussed, the 7 OSI model, these layers are categorized into two categories. Hardware layer. Hardware layers means all those layers which are related to the hardware, are where hardware works. For example, physical layer, data link layer, and network layer. So these layers are related to the hardware, and some sort of hardware's work on that. For example, we can say that on the physical layer, the cables are connected there, the hub is connected there. So some sort of devices are connected to the physical layer, some sort of devices work on the physical layer. On the data link layer, switch works there because MAC address are there. Ethernet work on the second layer. We connect the local area, we design, create the local area network on the data link layer. So the switch are some sort of devices work on the data link layer. The third layer, which is actually a network layer, it established a network. Their network devices, the devices which can understand the IP work there, for example, the router work there. So as these devices, some sort of devices are connected to the physical data link and network layer, so we say that these are the hardware layer. And other layers which are called a software layer, or you can say the upper layer, these are the transport layer, session layer, application layer, presentation layer. Actually in these layers some sort of application or some sort of software works there, and this is the reason we call this that these are the upper or software layers. This was the basic categorization of the OSI model, and this work and this categorization and their working. Now further we will cover in detail that how actually each layer works and how data is transferred from one location, from one computer to the other computer on the computer networks. Okay, let's go toward physical layer. Physical layer is the most lower layer which is connected to the hardware, to the physical devices. And this is the reason it is usually called a physical layer, because this layer connect our computers, our devices to any type of physical medium or the physical devices. The physical layer is basically responsible to transmit the data, to transmit the bits in the form of zeros and ones, and to convert our bits, to convert our data into some sort of signals. Because when we, for example, if at that time our computer is connected to any type of ethernet cable, or it is connected to any type of Wi-Fi, so the physical layer is responsible to convert our data to the ethernet, to the electrical signals, or to the radio, for example any electromagnetic waves, or for example if there is any optical cable, then the physical layer is responsible to convert our data, transmit our data in the form of optical signals. So all these things, all these related works are controls are done by the physical layer. You can understand the physical layer by comparing it, by assuming it as roads where the vehicles particular travels, the conditions of the road, either it is a highway, either it is a single road, or it is a very we can say a village road where the vehicles very difficult to travel. These roads actually determine how much vehicles should travel on this road, and with how much maximum speed they can travel on these roads. So the physical layer exactly like that, it control that how much data this computer or this device should send onto the particular cable. For example, the twisted pair cables have their own speed, the coaxial cables have different speed, the fiber optic cables have different speed. So they control also where the physical layer is responsible to convert the data into the signals. Similarly, it is responsible to control the rate of data, the how much data should be sent there. Along with that, it uses a different type of encoding scheme. For example, non-return to zero encoding scheme, the Manchester scheme. These are actually the schemes which convert our data into the signals, and after that this signals is transmitted to the cable or any wireless transmission media. So you can see that physical layer, this is the most lower layer, and it is responsible for number of tasks, as we discussed the bit transmission, discuss the transmission media, it control the data rate. As I give one example, that the traffic rate depends on the roads. So that if the roads are good, for example, this is any sort of highway or this is a motorway, then more vehicles travel there. But this is a single road, then only few vehicles travel there. It is responsible for different type of encoding and modulation to convert our data into some sort of signals, for example, non-return to zero and Manchester, etc. It is also responsible for the synchronization, to synchronize one device to the other device. And similarly, the physical topologies which we discussed in our basics, that there are different sort of topologies to connect computers in the computer network. For example, the bus topology, the star topology, ring topology, the mass topology. So the mass topologies, all these topologies are also come under the physical layer. All sort of transmission media, either it is a twisted cable, twisted pair cable, it is a coaxial cable, it is a fiber optic cable, it is a electromagnetic waves, it is a radio waves. All these comes under the physical layer, and physical layers are responsible to transport data on these communication medium. And according to this communication medium, for example, the ethernet cables use electric signals, the fiber optic use electrical signals, the wireless communication mode use the electromagnetic waves. So it also cover these signals and how data is converted to these signals to be communicated to the next devices. So along with that, there are some sort of challenges with the physical layer. For example, the data attenuation, the data loss, the bandwidth issue. These are some issues which are related to the physical layer. We saw that the physical layer converts the raw bits into signal. It gives the bits in the form of signal to the transmission media and transmitted on the transmission media. But how this is transmitted, in which form they are transmitted, what type of unit is there to transmit the data on the computer networks. The second layer, which is actually a data link layer, it take these bits and it convert these bits in the form of frame, which is basically a unit of the data link layer, to transfer this data in the form of frames. It is just like any worker in the postal office which receives some sort of data, some sort of letters, and it wrap it up and write the senders and the receiver address under it. It is exactly like that. Actually, how the frames, which is a basic unit to communicate on the computer networks, the data link layer, it is a basic unit. So what this unit actually contain? This unit, the first thing, it contains the data which should be communicated from the device A to the devices B. These are the bits of the physical layer. And after that, because this data to be sent from one device, this is some sort of sender device, and there should be one receiver device which will receive that. So the frame, the data link layer should write the sender address and the receiver address. And secondly, because the data link layer is responsible to look at the error correction, error detection, so it will attach some sort of checksum, some sort of monitor to control that all the data, all the bits are successfully communicated, successfully transmitted on the computer networks to the cables to the medium, and it is successfully received on the second device, on the device B. So for that purposes, it attached some sort of checksum, some sort of monitoring into the frame. Along with that, it also attached some sort of frame, that the what type of frame is this. Either this is a wireless frame, wireless network frame, or either this is a Ethernet frame. So the data link layer actually converted the bits into some sort of frame, which is a basic unit to communicate on the data link layer. It wrote the senders and receiver address there. It wrote or labeled this frame with the data type, the packet type, and some sort of checksum or some sort of monitoring. So if we look at it into further detail, we come to know that actually there are two tasks. We can categorize the data link layer into two basic categories or two basic sub layers. So we see the basic working of the data link layer. These are the two that it addresses the error correction. It correct the address. It correct the error in the data, which is done in the sub part of the data link layer. It a logical link control, where error is detected and corrected. And the second one is the medium media access control, which actually deal with the MAC addresses, where it receives the sender and receiver addresses, and this is responsible to take the data from the sender and send it to the exact destination, to the exact addresses. The protocols, the basic protocols which works on the data link layer is the Ethernet, the Wi-Fi. Ethernet is actually the wide local area network, and similarly the Wi-Fi, which is actually a protocol IEEE 802.11, which works there. And similarly there is a point-to-point protocol. All this clear that all the local area communication, local area network communication, either this is a network, either this is a wireless, or either this is a point to point, all the communication related to the local area network, related to the Ethernet, all is done by the data link layer, and the data link layer is responsible for their correct communication in terms of error correction, error detection and error correction, and the terms of their addressing, to take the data from the sender and to not broadcast it to the every devices, but to send it to the particular MAC addresses, to the particular device. As we saw, the data link layer was responsible to communicate on a single local area network. But when we talk about the internet, there is not a single network. There is a combination of thousands of network, the hundreds and thousands of network, and we have to connect all these networks together, and we have to communicate among these networks. When we communicate in among more than one networks, there are more than one computer networks, this is a wide area network, there will need a network layer. So network layer is actually responsible to communicate more than one network, or to communicate between or among different networks. In the data link layer, we saw that we actually used the MAC addresses. The MAC addresses are actually used in the local area network to identify the computers in a single local area network. But when we talk to the wide area network, there is not a single local area network. There are multiple local area network. Their MAC addresses not work. Actually, we need IP addresses there. Every computer have their IP addresses, and their IP addresses are used actually to send data from one place to the other places. And similarly, in the data link layer, in the local area network, we use the frame as a data unit to communicate data from the sender to the receiver, because there we used the MAC addresses, and MAC addresses were part of this frame. But in the network layer, when we communicate on the internet or among many computer networks, we use packets, and packet uses the sender and receiver IP addresses. This may be IPv4 or IPv6 instead of the MAC addresses. Switch was used in the packet layer to recognize the MAC addresses, but in the network layer, we use the router to route the data to understand the IP addresses of the packet and to send the data from sender to the receiver. So if we explore the packets, that what is actually inside the packet, that the packet have one header related to the addressing, which is IPv4, for example. So IPv4 will have the detail that what is the sender devices and what is the receiver devices, what sort of IP addresses there, and if there are any type of port there. The second thing it discusses that what type of other, for example, the UDP and TCP protocol, which we will discuss later in the transport layer. It also includes that what sort of protocol is used to transmit this data from the sender to the receiver. And similarly, as there was some sort of check or checksum in the frame, same sort of check, some sort of monitoring we used in the packets too. The basic protocols, as we saw in the network layer, that it is actually responsible to connect the wide area network, to connect many local area network together, and Wi-Fi is used. So the basic protocol which actually work here is the IP protocol, which is actually IP addressing, the IPv4, the IPv6, and definitely we use the internet control message protocol, which is basically used to diagnose the network. And you usually use the ISMB protocol to diagnose or to check your network. For example, when you use the ping command, in the ping command we send 4 packets to any destination computer or the destination device to check the reliability of the network, that how the network is reliable, how many routers are there through which our packet is communicated, and how much time is required to communicate these packets between the sender and the receiver device. So along with IPv4, along with the IP, the internet control message protocol is also used there. The router is a hardware device which is responsible to route the packets in the computer network, because in the data link layer we use the frame. Similarly, to understand the frame or to understand the frame addresses, which were MAC addresses, we use the switch there. But in the network layer, we are using packets, and packets have the IPv4 address or the IPv6 address. So we need the router to work there, because the router is a device which works on the IPv. They can understand IP, they can route the IP, and they can find the best routing addresses to send the data from the sender to the receiver. As the router is responsible to find the best route, so there must be some sort of routing protocol too. For example, the open shortest path first RIP protocol. There are also some sort of protocols which work there to route the data from sender devices to the receiver devices. So if we look in review the network layer, we come to know that it is just like a GPS system which you turn on in your vehicle when you travel on the roads, and the GPS uh, check the routes and suggest you the most suitable route from your home to your office, or from your source to the destination. Exactly, the network layer do like that. Exactly, the routers do like that, that it works just like a GPS. There are a number of routes, there are a number of roads, but it suggests you a most suitable, most optimum route from the sender to the receiver. And this optimum means that this route is optimum in terms of cost, in terms of performance, in terms of delay, and in terms of congestion. To review the network layer, it is responsible for logical addressing, it is responsible packet forwarding. It also, the network layer is also responsible to diagnose the network, to diagnose the route using the internet control message protocol. The basic protocols which work on the network layer is the internet protocol, the internet control message protocol, which is actually a ping command and related other commands which we used. And there are some sort of routing protocol, for example, OSPF, open shortest path first. There is a RIP, routing information protocol, broader gateway protocol, and number of other protocols which are used to communicate on the network layer. One thing which I forgot is the network address translation. Basically, when we create network, when we only talk about that there is any IP address and every device has their IP address. But IP addresses are two types. On the network, there are two type of IP addresses. One is the private IP address, and one is the public IP address. Private IP address means that in the local area network, the router give you one address for the communication. This is your local area IP address. This is a private. You know about this IP address. The local area network know to this IP address. But after crossing the router, no one understand this IP address. This is nothing on the internet. For the internet, the router provides you one public IP address, and this public IP address you communicate with the other devices on the network. So if you are communicating in the local area network, there is some sort of IP address which is called a private address, and when your data is sent on the internet on the wide area network, you are provided one public IP address. So they will need some sort of translation from private to the public IP address and from public to the private IP address. So the protocols which do that, or which is responsible for the IP address translation, is the network address translation NAT, which is responsible for the translation. I also forgot to discuss the IPv4 structure, because IPv4 is basically the address which is used on the internet. It is a 32-bit address where the IPv6 is a 128-bit address. 32-bit address is divided into 4 octets, and these octets are divided according to the network octets and the host octet. For example, this is a class A address. Then class A address means that the first octet is for network and the other 3 octet is for host, where we connect the host. Or for example, there is a C network address where the first 3 octets is for network and the last one octet is for host. So these were the basic things related to the network layer, that how network layer actually play its role to communicate the data on the computer. The next is the transport layer, which we can say it is also a heart of the OSI model, where the physical layer was responsible to convert our data, to convert our raw bits into some sort of signal. The data link layer was responsible for framing to communicate in the local area network. The network layer was responsible to convert the data into packets, and it was responsible to communicate among many networks, to communicate a number of local area networks. Similarly, the transport layer is responsible to effectively or efficiently transfer data from the sender to the receiver. But what this efficiency means, what this effective means, that how this data should be sent, transmitted efficiently or effectively. Actually, the transport layer, which is responsible for the transportations, works on the 2 basic protocol. The one is the TCP protocol, and the second one is the UDP protocol. Or you can see, if you are not going to discuss the protocol here, then you can see that the transport layer communication is actually divided into 2 categories. One is reliable communication and one is the unreliable communication. Reliable communication means that where we cannot accept any sort of error. For example, sending an email, sending text, sending any some sort of file. So in these file, if If any type of error, for example, bit or bust error occurs, this file wouldn't be open at the receiver and there may be any we can say that this file may not be useful for the receiver, because every bit is important there, every bit play its part. And so we use the reliable communication where we ensure that every bit reaches to the destination. The second is the unreliable communications, where there is no such importance and the every bit is important in the reliable communication. No such priority is given that every bit should reach there. So if we are not going to ensure every bit in the receiver, we shouldn't have we don't have a complete structure to ensure every bit. Definitely, if the communication is unreliable, its speed would be faster. For the reliable communication, let's go towards its protocols. For the reliable communication, we use the protocol TCP, and for the unreliable communication, we use the protocol UDP. So how the TCP actually works? The TCP means that both the computers handshake, they establish a connection, they send a connection, the receiver acknowledge that, and after this they start the communication, they define the window size, that how many packets should be sent, and when these packets are received, the acknowledgement is sent that the packet is received. So after that, the sender once again send the next packet or packets. And if there is some sort of bit or burst error, or if any segment is missing, if any packet is missing, the receiver requests again for these segments or these bytes, and these bytes are once again sent from the sender to the receiver. So when if all the data is successfully transferred, there is a procedure to end the connection. You can see in the TCP how this works actually, how perfectly this ensure that all the data is sent and all the data is successfully received. It establishes a connection. After that, it sends the bytes, it sends the packets, the receiver acknowledges the packets, and after that, when all the data is sent and received, the connection is closed. So it is very efficient, it is very reliable. On the other hand, UDP working is completely different. There is no handshake, there is no connection establishment, there is no acknowledgement. The sender just send the data towards the receiver and the receiver receive it. And if there is any missing packets, there is no acknowledgement, there is no request to send these packets. So this is unreliable communication, because there is no handshake, there is no termination or closing of a connection, there is no acknowledgement. So this is faster, this is very faster compared to the TCP, but it is unreliable because the packets may miss, the bit or burst errors may occur, and we would not be able to send or receive all the data exactly as it is transmitted from the sender. But where do we use the UDP? We use the UDP where we need the speed, where the all bits or bytes are not important. For example, when we use the internet for streaming, we use the for video calling or voice over IP, or similar other type of communications where every bits or bytes are not important. Along with that, along with the TCP and IP, it also has a protocol which is called a transport layer security. It also ensures the security on the transport layer 2 to securely transfer data from the sender to the receiver. Along with this protocol, the transport layer also uses the port number. Port number is very important in the communicating on the computer networks. Port numbers actually define the services, that what type of service, what type of application actually you are communicating. For example, the HTTP uses a port number 80, HTTPS uses the port number 143, and there are a number of different services. The email uses their own port number versus WhatsApp will use their own port number. So this actually differentiate the application, this differentiate the services on the transport layer. The next one is the session layer, as it is clear from the name session that it is responsible to maintain the session between sender and receiver. Session means, for example, if we are going to conduct any class, then there will be any timetable. This timetable is available to the student. This is available to the teachers. So students following these timetables go to any particular classroom, and similarly the teachers also following this timetable go to any particular classroom, and the session start, the class start. Exactly as the timetable manage the session of students and teachers for any particular class, the session layer is responsible to maintain the session of any communication, of any dialogue, or any file transmission. And the session layer is not only responsible to maintain the session, it is also responsible to transfer the large files on the computer network efficiently. For example, if you are uploading any video, which is a, you can say, a massive video, a large volume of video on the YouTube or the Facebook, and the session terminates in the middle, or the connection terminates, and when you reconnect to the internet and you want to upload it again, it start the uploading from the location. It check the point that how much data was already uploaded, and where this should start the uploading the video, instead of uploading all the data from zero. So this is the session layer, which help in uploading the large files, to maintain the session, to check the point, and somewhere if the session terminate, it helps to synchronize the transmission again. Along with this session, it also help us in the authentication, authorization, and which help us in the maintaining the session. The protocols which usually work on the session layer are NetBIOS, point-to-point tunneling protocol, and RPC protocol. Along with the session, it is also responsible for the dialog control, to check that either it is a simplex mode, it is a half duplex mode, or it is a full duplex mode. The next one is the presentation layer, as it is clear from its name that it is responsible to present the data. It is responsible to send the data in a particular format. For example, if our data is transmitted, there must be any encoding scheme to convert this data into particular bit scheme. For example, the ASCII is particularly used, and when we send the photos, the JPG, etc., are used. Along with that, it presents the data in according to the particular application. For example, the data when it travel on the computer networks, on the cables, in the wireless mode, or any communication device, these are just like a bit. These are the raw bits. But when it comes to any particular application, you see that the data is represented in a particular format. So for all that, the presentation layer is responsible. Along with the encoding scheme, the encryption and decryption is also done on the presentation layer. So we can say that the presentation layer, along with the encoding schemes, encoding the data, it is also responsible for the security, safety, and privacy of the data, because we do the encryption here. Encryption means that when we want to send data on the computer network, instead of sending the data in the same format, we just change its format so that it may not be readable or understandable by any person. There are number of encryption techniques which are used for the security, And for example, if you take example of the WhatsApp, when you use the WhatsApp and you send any message to a new person, you instantly get a message from the WhatsApp that this connection is encrypted, this connection is secure, which means that the data which you send toward the sender, to your friend, before sending this data to the network, transmitting the bits to the network, it is encrypted, and when this data is received on the receivers at the destination, this is again decrypted according to the particular algorithm which is understood by the sender and the receiver application. So presentation layer is responsible for encoding, and it is also responsible for the encryption and decryption techniques, which is usually called the security of data. The last one is the application layer. Application layer is just like a physical layer, connects the communication to any physical devices, to any physical layer, any physical you can say the cables where we transmit the data to the network. The application layer exactly is the end of the OSI model, which connect the users, the data generator, to the computer network. It facilitates us, it gives us an authority so that we may communicate on the computer network. For example, at that time, if you are watching this video on the YouTube, so YouTube is giving you authority to communicate on the computer network. And if you are using the Facebook and you are watching this video on the Facebook, so this is the application, this is the Facebook, which as an application give you authority to generate data, to receive data, to communicate on the computer network. This is the reason this is called application layer, because this connect users to the computer network. Number of protocols work there. For example, the HTTP hypertext transfer protocols, which is responsible to transfer the text. HTTPS, which is actually secure version of hypertext transfer protocol. The file transfer protocol, which is basically responsible to transfer the files. The mail transfer protocol, which is responsible for the mail. So number of other protocols which are used on the application layer to communicate on the computer network. So these were the, you can say, the sharp background of the OSI model, that how the network devices communicate on the computer network using the different 7 layer of the OSI model. So to wrap up, we should summarize, we should review with one example, that how actually 7 layer put their efforts to communicate on the computer network. Physical layer is the first layer to communicate on the computer network, but physical layer is the ending layer to transmit or generating data to the computer network. So when we connect to the computer network, to any application, for example, you are using WhatsApp to write some sort of message, or you are using email to write some sort of message, or any official message to send to your fellows, or you are uploading any YouTube video or a Facebook video, or you are sending any other thing on the computer network, the first thing, you connect to the application, any sort of application. You connect, you open the WhatsApp, you open your email, you open your YouTube, you open your Facebook application, etc. So these are the applications which allow the users to connect to the network to generate some sort of data. So when data is generated, the second phase is that we should convert this data in the form of bits, some sort of digital data. For that, for example, we use the ASCII methodology, American Standard Code of Information Interchange, which is actually a code which convert a text, which convert our some sort of data into the form of bits to represent our data, to represent our text, numbers, photos, colors, etc. in some sort of you can say bits. When this is converted, the next one is the session layer. Session layer means that A session will be maintained with the sender and the receiver devices. When the session is maintained between the sender and the receiver devices, so the next task is to communicate this data from the sender to the receiver. Let's repeat this again. First was the application layer, which helped the users to generate some sort of data. When data was generated, the next one is the presentation layer, which use some encoding techniques, for example ASCII, to convert this data into the digital format. And when the data was converted to the digital format, there was a session layer to maintain the session between sender and the receiver. So when the session is maintained, we have to transport this data from the sender to the receiver, and for this one we use transport layer. Transport layer provide two types of protocol: the reliable communication and unreliable communication, TCP communication and the UDP communication, and we use this protocol to transfer our data from the sender to the receiver. Next one is the network layer. The data coming from the application layer, we are adding some sort of heading. When it comes to the network layer, this is converting to the packets, and these packets have the senders and receiver addresses, and the devices router which actually work on the network layer, which is responsible to search the optimum path to send the data from sender to the receiver. After that, the data link layer come, which convert the data into frames, and the data link layer actually works on the local area network, where the data is delivered in the local area network. The last one is the physical link layer, which actually convert the data which was generated by the presentation layer in the ASCII format, which is then converted into signals. The bit is converted to the signals. If the data is transmitted on some sort of Ethernet cable, it is converted into electrical signals. If it is sent by Wi-Fi or any other wireless communication medium, it is converted to the electromagnetic waves. And if it is transmitted on the fiber cable, then electric lights are used, electric signals are used, sorry, light signals are used to send the data on these yes, medium. So this was a detailed review that how actually OSI layer works, how OSI layer transfer data from one device to the other device. Thank you so much for watching.